right. What is expected of us is to apply the laws of logarithms as before, but this time around intending to have that unknown obtained. Now, on this first step, this would be the same as the logarithm of x squared plus the log of 6. This is equal to 1 plus the log of 15. Without any other step wasted, I want us to remember that 1 is the same as log 10 to base 10. I want us to remember that 1 is the same as log 10 to base 10. 1 is the same as log 10 to base 10. 1 is the same as log 10 to base 10. 1 is the same as log 10 to base 10. So, but these logarithms have been put down without any base on them. Reason, it's base 10. That's what we expect everyone to be aware of. So this is log 6, which is equal to log 10 there plus log 15 plus log 15. So resultantly, log x squared plus log 6 becomes the log of x squared multiplied by 6, which is equal to the log of 10 multiplied by 15. And that leaves us at a stage of writing log 6x squared being equal to the log of 150. So the rule to appreciate here is log of a base x, if found when equal to log of b base x, then a is equal to b. Then a is equal to b. Then a is equal to b. So at that stage, with application of the law as mentioned, it implies that 6x squared is equal to 150. Let's use the chart to talk to me. Is that understood? Is that step understood? Are we so far okay? Send a message or send a text in the chat to alert me. So far, are we good? Putting down a logarithm, answering Victoria, putting down a logarithm without a base, it means that base is 10. Don't forget that. It means the base is 10. Okay? I see Deborah says yes, so Job Grace says yes, Benson yes. Any other? I want to us to be at the same point. David is also okay. Those who do not know the chat, I mean where you can send a message. Type there something to confirm that you're following. Okay, that's good. So 6x squared. 6x squared is equal to 150. And that means at that point we are supposed to divide both sides by 6. So x squared will equal to 150 divided by 6. 150 divided by 6, which gives us a 25. And that implies that for one to solve for x, that person will have to take the square root of 25, or square root of x squared, which is x. This gives us a plus or minus 5 However, the value of x to give, the value of x to take should be the positive value. The value of x to take is the positive value. And the value of x to take is the positive value, which is 5, not negative 5. But keeping in your mind the fact that being x squared, those are two solutions, but you give us the positive value of x. That is our example 1. That is our example 1. Example 2. Example 2. Example 2, or what we can refer to as Roman 2. Roman 2 is here. Roman 2 is there. We want to solve for x again. Solve for x in this equation, Roman 2. So when solving for x, this time around we are interested in checking the property to begin with of subtraction of logs. So when subtracting logs, what do we know? When subtracting logs, rule to link on log of a base x minus the log of b base x is the same as, can someone remind me, which single log can we write when you have a difference of logs to the same base? Good. Log of a divided by b base x. Good. People have mentioned it. So that means this side, what should we write on our first step? Can I have anyone to submit? What should we write this time around? On the first step, what should we write? Feel free to switch on your mic. Feel free.
Log of 3x plus 1 divided by x minus 1 base 10 equals to log of 4 base 10.
Base 10, that is equal to the log of 4 base 10. From my number 1, what's the next step? What's the next step? From the way I attempted in number 1, what should be the next step? From there, anyone to submit? What should be the next step, class?
3x plus 1 over x minus 1 is equal to 4.
3x plus 1 over x minus 1 is equal to 4. And this is over 1. When you cross multiply, 3x plus 1 will equal to 4 into x minus 1 into x minus 1. So on the next step, we'll simply have to correct like terms. 3x plus 1 will equal to 4x minus 4. Bring this x this side. 3x minus 4x plus 1 is equal to negative 4. This is negative x, which is equal to, now this positive 1 also process to give us a negative 4 minus 1. So negative x is equal to a negative 5 there. It's a negative 5 there. And when you divide both sides by negative 1, when you divide both sides by -1, it means x is equal to 5. It will mean x is equal to 5. So this in example 2, the value of x to take, value of x is 5. Value of x is 5. Someone might think every time the answer must be 5. No, that was just a coincidence. Roman 3. Application of laws in solving equations. Application of laws in solving equations. Roman 3 is here. Roman 3 is here. Roman 3 is here. Okay. Okay. What should be the first step? Can I have a boy this time round? What should be our first step when solving for x here? Let's have a boy contribute on the procedure to take
log of x plus 3
yes
divided by x minus 3.
Okay, it becomes log of x plus 3, log of x plus 3 divided by x minus 3, to which base? To which base, Sebo? Base 4 is equal to 2. What's the next step? Next. I think we discussed how to change that 2 into a logarithm. What should I do to that 2 for it to become a logarithm? Any submission, members? Someone would write that as, this is approach 1. Someone would write that as the logarithm of x plus 3 over x minus 3 to base 4 equal to 2 times 1. That is the same as 2, but that one I'm introducing, I want us to write it as a logarithm to base 4, which is 4 base 4. Then substitute. This means this will be log of that quotient x plus 3 over x minus 3 to base 4, which is equal to 2, the logarithm of 4 base 4. And then at that instant, then now that 2 can become a power of that quantity. It can become a power of that quantity. And where will we be? Where will we be? Where will we be? So what we are now ready to say is that that logarithm of x plus 3 divided by x minus 3 to the base 4 is the same as the logarithm of 4 squared, which is 16 to the base 4. Because 4 squared is 16, upon that becoming the power of 4. Let's use the chart to talk to me. Is that step okay? Is that step in light blue? Fine. Is that step okay? Please reply in the chat. Let's reply in the chat. Mulinda, Brenda has given me feedback, is okay. What about the others in the call? Are we good? Is that step okay? Yoel is okay. Any other? Any other? Okay. Okay, that's good. Alan, Jambo, Kunch, Watua, that's good. And that's good. So we can proceed. So at that level, we can now apply the principle that we have been applying. X plus 3, the powers will now be equal over x minus 3 will equal to 16. But that 16 will be over 1 fraction wise as a whole number, then cross multiply 16 into x minus 3 is the same as x plus 3 times 1 times 1, which is that. So 16x minus 48 will equal to x plus 3. Correct like terms, 16x minus x is equal to 3 plus 48, which becomes 15x here, giving us a 51. So dividing both sides by 15, what will be our value of x then? What will be our value of x in that regard? What will be our value of x then? Remember, this is 51 over 15 over 15. 51 by 15. 51 by 15. Therefore, we can be able to conclude that x is equal to, who has got that value? 51 over 15. Which decimal do you get? Which decimal do we get, class?
3.4.
3.4. Good. 3.4. Good. That's good. So, therefore, the value of x, is 3.4. The value of x is 3.4. The value of x is 3.4. The value of x is 3.4. Okay. Next. 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 Next is as simple as that. Our Roman 4 is as simple as that. Solve for x in this equation. Solve for x in this equation. This is our Roman 4. Okay, I'm giving you just a few minutes to think of what to submit. Okay, that's good enough. Can we have any submission? Anyone with an opinion? Anyone with an opinion? How would we do that? How would we do that? How would we do that? 5 power x is equal to 9. 5 power x is equal to 9. To solve for x in such numbers, um, if this was 5 power x equal to 25, we all know what to do. We would use our indices and write 25 as 5 squared, and then say x is equal to 2. That's what we have knowledge about. But this time round, we want to deal with a quantity which can't be expressed as an index of the unknown index statement. So what you do, you introduce uh, you introduce you introduce logs, you introduce logarithms, you introduce logarithms to base 10, both sides. You introduce logarithms to base 10 both sides. So 5 power x equal to 9, you will introduce the log to base 10 his side and the log to base 10 the other side. And at that level, you will have x the log of 5 base 10 when it is equal to the log of 9 base 10. So what is the logarithm of 5? Press your calculators. Log 5 is what on the calculator? Can someone give it to me? Log 5 on the calculator. What do you get? Log of 5. If you've pressed your calculator, what do you see? Point
0.698970004.
Give me 4 decimal places. I think it will be 990. What about log 9? Thank you. What about log 9 to 4 decimal places? Log of 9 to 4 decimal places. What do you see?
0.9542.
9542. So that means this is the same as 0.6990x, which is equal to 0.9542. To make x the subject, we will divide both sides by 6990 by 0.6990, that way. So x is equal to 0.9542 divided by 0.6990. You get 1.1365651 for decimal places as the value of x. of x, as the value of x there. That would be the solution for that kind of question. So similarly, you can be told to solve. Similarly, you can be told to solve. That's Roman 5. Can be told to solve 3 power x is equal to 5. 3 power x is equal to 5. Introduce logs to base 10 again. The log of 3 to power x is equal to the log of 5. Remember, without a base, it's base 10. So x log 3 is equal to log 5. That x drops. It's the only way you can make it a subject. Then substitute log of 3 and log of 5. Who has computed log of 3? Who has computed the logarithm of 3 to 4dp? You help.
0.4771.
Yes. 0.4771. Thank you. Log 5. Log 5.
0.6989.
0.6989.
89.
Round off to 4 decimal places. When you round off, you get what? It is 990. You have 0.69897. So when you round off to 4dp, this is above 5, it adds a 1 here to give us 10 carry 1, you get 990. 6990. Madam, you should learn that rounding off. So this is now the same as 0.4771x, which is equal to 0.6990. So divide this by 0.4771 by 0.4771. So x will be 0.6990 by 0.4771, which is a 1.4651. So therefore x, the value of x is equal to 1.4651. The value of x is equal to 1.4651. Okay, next, Roman 6. Solve. What if it was 2 power x plus 1? Power x plus 1, when it's equal to, say, 7 to power 2x. The procedure doesn't change. We will expect learners to apply logs to base 10. Log of 2 power x plus 1. There is an expression this time, you have to be careful, is equal to the log of 7 power 2x. Drop the power x plus 1 is multiplying log of 2. This is equal to 2x multiplying log of 7. So can someone compute for us the log of 2 and then the log of 7? to 4dp on the calculator. What does it give you? Can someone compute that? What's log of 2 on the calculator?
0.3010.
0.3010. 3010, not so? Okay, what about log 7? What about log of 7?
0.8450.
45. After 0, what's the next digit?
0.88450.
Round off to 4dp. What's the next digit after 0? Someone should be able to round off. It's beyond 5. So it is what?
1.
5, 1. Then expand. Let's get those concepts. Let's get those concepts back of rounding off. Expand, you will get 0.3010. It is going to expand into that bracket. Then that is equal to 2 into 0.8451 multiplying the x. So when this opens up, this will be 0.3010x plus 0.3010 equal to that times 2, open 2 times 0.8451, you get 1.6. You get 1.6902x. Correct like terms 0.3010x. Bring this quantity to the left. Bring that quantity to the left. It will be a minus 1.6. I think it's better the other way around. It will be convenient the other way around to take this the other side and remain with 0.3010 without x in it will equal to 1.6902x minus the minus the 0 point minus the 0 point minus the 0 point minus the 0.3010x. So this is 0.3010, which is equal to 1.6902 minus 0.3010, which is 1.3892x divided by 1.3892 by 1.3892. So therefore x is equal to 0.3010 divided by 1.3892, which gives us a resultant as 0.2167 when you round off to 4dp as the value of x. So for that matter, therefore the value of x is equal to 0.2167, and so on and so forth. That is another solution for the value of x. Similarly, it can be in line with solving, but when you're dealing with simultaneous equations. Let's look at this as number 2, not a Roman then. Number 2, solve the simultaneous equations. So if I'm to rewrite this for someone who is not seeing it properly, log of 2x plus y to base 10 is equal to 2. That is our equation 1. And the log to base 10 of 5x plus 3y is equal to 2 as well, and that is equation 2. We want to solve those two equations simultaneously. So the question is, how will we go about that? So how can we solve those two equations? Which law are we going to recall? Which law are we going to recall, to mention? Which rule are we going to recall? We have to recall the law of changing logarithms into index form, where when given log a to base x, when it is equal to some value, say y, then x to power y is equal to a, by laws of change of logarithms into indices. So what will our equation 1 become with respect to that law? 10 to power 2 should equal to 2x plus y. Therefore, 2x plus y at that point, it seems it is equal to 100. That becomes my equation 1. In the same line, 10 to power 2, 10 to power 2 in equation 2. There was an oversight here. These bases were not the same. This is base 3. This is base 3. This is base 2. So that means something slight here must change. They were not similar bases. So this will be 3 squared, which is 9 this side. Then 2 squared should equal to 5x plus 3y. So therefore 5x plus 3y is equal to 4, and that becomes our equation 2. So what is our task now? Our task is to solve those two equations simultaneously. Solving
How should?
Solving 1 and 2 simultaneously. Solving equation 1 and 2 simultaneously. Solving equation 1 and 2 simultaneously. So I'm going to multiply equation 1 by 3 so that I eliminate y. Equation 1 will become 6x plus 3y equal to 27. But my equation 2 remains 5x plus 3y, which is equal to 4. Subtract the two equations for y to cancel. This will be x equal to at 23. And if that is so for x, recall that equation 1, which was 2x plus y equal to 9. Y is 9 minus 2x. So that is 9 minus 2 into 23, which is actually 9 minus 46. So what's that one? That's negative. Y will be negative, negative 37. So therefore, in this kind of question, the value of x, the value of x is equal to 23, and y is equal to negative 37, to mention. You've solved for x and y. You've solved for x and y, just like in the other questions where you were solving for an unknown. In the next opinion, I would love us to do on our own these numbers here. Solve for x in the following. 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 Let's attempt these questions. Solve for x in the following. So this is our exercise. This is part A, part B, part C. Solve for x in the following. That is, and lastly, part D. Part D, I'll add something. Here. If it was addition, what would the learner do? Solve for x in the following numbers. So those are for our trial purposes. Any question?